Now let's try applying the binomial theorem to expand the same binomial expression right here. And the binomial form of this binomial expression raised to the fifth power is a summation from k equals 0 all the way to 5 of the products of 5 factorial over k factorial multiplying 5 minus k factorial. The first term x squared raised to the 5 minus k, and the second term negative 1 over x raised to the k. So since this is a summation, we are going to be repeating this entire product here for each of the k values, starting from the lower limit of summation k equals 0, and then go all the way to 1, 2, 3, 4, and then eventually 5. So starting with k equal to 0, we are going to have 5 factorial over 0 factorial times 5 minus 0 factorial multiplied by x squared raised to the 5 minus 0 multiplied by negative 1 over x raised to the 0. Well, this is easy. 0 factorial is going to be positive 1. 5 minus 0 is going to be 5. 5 factorial over 5 factorial. These two cancel out. So we're left with just positive 1 over 1 times 1, which is just 1. 1 over 1 is just going to be 1. So this entire thing is positive 1. 5 minus 0 is 5. X squared raised to the 5th is going to be x to the 10th. Anything raised to the 0 is going to be positive 1. So really, we only have 1 times 1, which is 1, and then 1 times x to the 10 is going to be x to the 10. Now if k equal to 1, same product, but now replace all of the k with 1. So we got 5 factorial over 1 factorial times 5 minus 1 factorial. X squared raised to the 5 minus 1 times negative 1 over x raised to the first. Well, let's see. I'm going to expand it out a little more. 5 factorial, I'm going to rewrite it as 5 times 4 factorial over 1 factorial is going to be positive 1. 5 minus 1 is going to be 4, so 4 factorial. 5 minus 1 is going to be 4. X squared raised to the 4 is going to be x to the 8th. Negative 1 over x raised to the first is going to be just negative 1 over x itself. 4 factorial right here cancel out. So we're left with just 5 over 1, which is 5, times 8 times negative 1 over x. So this is going to be 5x raised to the 8th over x. Oops, this is going to be negative. But x to the 8th over x is going to give us x raised to the 7. So this is going to be negative 5 times x raised to the 7. Just like that. As you can see, when k equals 2, the same thing. We got 5 factorial over 2 factorial times 5 minus 2 factorial times x squared raised to the 5 minus 2 times negative 1 over x raised to the second. 5 factorial, I'm going to rewrite it as 5 times 4 times 3 factorial over 2 factorial times 3 factorial. Yeah, 5 minus 2 factorial is 3 factorial. These two 3 factorials cancel out. 2 factorial is going to be just positive 2. 5 times 4 is going to be 20. 20 divided by 2 is going to be just 10. So this, let's see, how should I say this? We'll cancel it out. This is just going to be 10, like that. X squared raised to the 5 minus 2, which is 3. So x squared raised to the 3, which is x to the 6. Negative 1 over x times, raised to the second is going to be positive 1 over x squared. You got 10 times x raised to the 6 times 1 over x squared is going to be positive 10x to the 6 over x squared. But this is going to be equal to 10 times x raised to the 4th. Now, if k equals to 3, same thing. 5 factorial over 3 factorial times 5 minus 3 factorial. Multiplying by the first terms, x squared raised to the 5 minus 3 times negative 1 over x times 3. Well, let's see. 5 factorial, I'm going to write it as 5 times 4 times 3 factorial over 3 factorial times 5 minus 3, which is 2, so 2 factorial. 3 factorial cancel out, but hey, this is the same as up here, so we know that this whole thing, let's say I'm gonna circle it. This whole thing is gonna be positive 10 again. And then bring down the, let's see, well, not yet, not bring down. 5 minus 3 is 2, x squared raised to the 2 is gonna be x to the 4th. Negative 1 over, negative 1 over x raised to the 3rd is gonna be negative 1 over x cubed. 10 times x to the 4th times negative 1 over x cubed is going to be negative 10 x to the 4th over x cubed. Like that. X to the 4th over x cubed is just going to be x. So this is going to be negative 10x. When k equals to 4, we got 5 factorial over 4 factorial multiplied by 5 minus 4 factorial times x squared raised to the 5 minus 4 times negative 1 over x raised to the 4th. And let me erase this number 10 real quick. Sorry about that. And this is positive 10. Well, let's see. I'm going to rewrite this combination as 5 times 4 factorial over the product of 4 factorial. And 5 minus 4 is 1, so this is 1 factorial, which is just going to be positive 1, by the way. 4 factorial cancel out, so we got 5 over 1, which is just going to be 5. 5 minus 4 is 1, x squared raised to the 1st is going to be x squared itself. Negative 1 over x raised to 4 is going to be positive 1 over x to the 4th equal 5 times x squared times 1 over x to the 4th is going to be 5 x squared over x to the 4th. But this can be simplified down to 5 over x squared, just like that. Now, lastly, when k equals to 5, we got 5 factorial over 5 multiplied by 5 minus 5 factorial multiplied by x squared raised to the 5 minus 5 multiplied by negative 1 over x, negative 1 over x raised to the 5th. Well, let's see. 5 factorial right here, cancel out. So we're left with just positive 1 and positive 1. 5 minus 5, 0. 0 factorial is going to be positive 1. 5 minus 5, 0. Anything raised to the 0 is going to be positive 1. Negative 1 over x raised to the 5th is going to be just negative 1 over x raised to the 5th. So really, we got 1 times 1, which is just 1. 1 multiply anything is that thing itself. So this is equal to 1 over x raised to the 5th. So adding all of these products together that we got right here, by the binomial theorem, we know that x squared minus 1 over x raised to the 5th is the sum of x to the 10th, which is right here, plus negative 5x raised to the 7. So minus 5x to the 7 plus 10 times x raised to the 4th plus negative 10x plus 5 over x squared, and then plus negative 1 over x to the 5th. So you see, the answer using the binomial theorem is the same as the answer using the Pascal's triangles.